Any questions regarding the block 2? Thank you. Our resource person is present here. Now he will start the session. Thank you. Take your seat. Admit करियो. Start. Start.
Good afternoon, sir.
Welcome to all of you learners to Indira Gandhi National Open University. Now I am going to teach you about the BM course code, that is your BMTC-133 block 2, which contains, that is your the block 2 contains, that is your limits of sequences and sequence and convergence. Perhaps this is these two chapters perhaps very new for you. Actually, you have already know about the limits, but the sequence and convergence, these are two new things. First of all, we'll describe about the definition of, that is your sequence, then subsequence, and what is bounded sequence, what is monotone sequence and a Cauchy sequence, then the criteria of convergence and a divergence, then algebra of convergent sequences, then is your Cauchy criterion of convergence, like this one. First of all, what do you mean by a sequence first? First of all, what is a sequence? A sequence, everybody know about what do you mean by function? Hello, Manoj Mandal. Hello, Manoj, Sony Baral.
Yes, sir.
Do you know what is function? Or it is easy for you? Do you know, already you have known it in your lower class. That is perhaps in 12th or 11th, you know, what is a function. From that thing, we'll go to the sequence. Simply a function, it has a domain and a codomain. If we operate an element in the element of the domain with the function, you will get an element in the range set or in the codomain. Or it maps the, or it corresponds or relates the elements of the domain to the elements of codomain. That is the function. So that a sequence, what do you mean by a sequence? A sequence is a mapping or a function f from n to r. N means that is the set of natural numbers and r is the set of real numbers. First of all, what is a real sequence first? A real sequence means it is a function. A real sequence means a function whose domain and the codomain both are the subsets of the real number set. Then that sequence is said to be a real sequence. First of all, what the real sequence means, it is a function f from n to r, where n is the set of natural numbers and the r is the set of real numbers. Everybody know what is the set of natural numbers and what is the set of real numbers. Natural in case of number system, n or natural number set is the smallest set and the set of real numbers is the largest set. In between these two, there are the set of integers, the set of rationals, the set of irrationals. These are the also the sets in case of number system. But our aim is to define a real sequence first. A real sequence is a mapping or a function from n to r. That is, it is a mapping from n to r. If, for example, if we write 1 in the domain, the element in the range will be, that is f1. If we write 2 in the domain, then the element in the range will be f2. For example, a sequence, let us xn is a sequence and xn is defined as, or fn is equal to xn and fn is defined as, for example, that is your 2n minus 1. When we write 1 in the domain, we will get 2 into 1 minus 1. If I will write 2 in the domain, in the range set, I shall get 2 into 2 minus 1. That is the function fn is defined as 2n minus 1. And in this case, the domain is the set of natural numbers and the codomain or the range set is the set of real numbers. Can you distinguish between the range and the codomain? Anybody? Jyoti Jana? Hello? Jyoti? Hello? Hello? Dear learners,
Yes, sir.
am I audible to all of you? What I am saying, is it audible to all of you?
Yes, sir. I have some network
Yes,
problem.
sir.
Please ask me. What is your problem? Please ask me.
No, I have some network problem.
Okay. Okay. Actually, what you have read in your 12th class or 11th class, it is some development in this degree level classes. Because we have already know what about the functions. But here is we are going to read about the real sequence. I have already told you that every real sequence is a function f from n to r. From n to r, where n is, in case of, hello? Dear learners, you should write your enrollment number in the chat box. That's why even you will be entered in the attendance. Please write your enrollment number in the chat box. That's why you will be registered in the attendance. All of you, those who have already joined, they should write their enrollment number in the chat box. For example, now I am going to give an example of another sequence, real sequence. Let fn is equal to 1 by n. When we write 1 in the domain, that is in place of n, what is f1? That is 1 by 1. That is 1. When I shall write 2 in the domain, that is your f2. that is equal to 1 by 2. If I shall write 3 in the domain, that is F3, that is equal to 1 by 3. Where the domains are the set of positive integers, but the elements in the range, they are the real numbers. And those real numbers, the set of numbers are real numbers in the range, and they are all, the entire set is the subset of the real numbers. So that the function f, that is a mapping from n to r, and that is called as a real sequence. That is fn is equal to 1 by n, when f1, f2, f3, these are the elements of the sequence. They are the elements of the sequence. Whereas that is f1 is equal to 1, f2 is equal to 1 by 2. I have already defined that fn is equal to 1 by n, f3 is equal to 1 by 3, f4 is equal to 1 by 4, f5 is equal to 1 by 5. These are the elements of the sequence. Those are the elements of the terms of the sequence. Then I am going to so that I had already, if I shall write another sequence, that is fn is equal to 1 by n square. Domain is the set of natural numbers and the range is the set of real numbers. I shall write 1 in the domain. What you will get in the range, that is 1 by 1 square, that is 1. If I shall write 2, f2 is equal to 1 by 2 square, that is 1 by 4. F3, that is equal to 1 by 9. These are the elements of the sequence. That is your 1 by, first is your 1, then 1 by 4, 1 by 9, then 1 by 16. These are the elements of the sequence. So this is the very definition of the sequence. That is, a sequence is a mapping f from n to r, where n and r both are the sets of subsets of the real number set. So that we say that the sequence f is a real sequence. Next, we will go to the next. Next, that is your next is your bounded sequence. First of all, it is a sequence. Then second thing is your bounded sequence. Means let xn is a sequence if xn is less than equal to k for every value of n, we say that the sequence is bounded above. If for small m, if xn is m is less than equal to xn for every value of n, we say that the sequence is bounded below. That is the if xn, if the sequence xn for every value of n, if xn is less than equal to k, then k is the upper bound for that set or that sequence. And if m is another number such that m is less than equal to xn for every n, then m is the lower bound for that sequence. Or if the sequence has upper bound, then we say that the sequence is bounded above. If the sequence xn has lower bound, we say that the sequence is bounded below. The sequence which is bounded above and bounded below, then that sequence is said to be a bounded sequence. A sequence which is bounded above and bounded below, that sequence is said to be a bounded sequence. Otherwise, the sequence is said to be unbounded. Any sequence which is only bounded above but not bounded below, that is not at all a bounded sequence. Or any sequence is bounded below but not bounded above, that is not at all a bounded sequence. The sequence is said to be bounded if it is bounded above and bounded below both. Next thing is your that is your monotone sequence. Anybody Priyanka Mishra. Hello. Priyanka. Hello. Manoj Mandal. Manoj. Do you follow that whether the sequence is bounded or unbounded? In which case this is said to be bounded, and in which case the sequence is not to say that it is bounded. Do you follow me? Hello, Manoj.
Yes, sir.
Till now, do you feel whether the sequence what I have told, that is your fn is equal to xn or fn is equal to 1 by n, that sequence is bounded above? That sequence that's fn is equal to 1 by n, is that sequence is bounded above? Fn is equal to 1 by n, is that sequence bounded above? Manoj, Barsarani Sahu, Barsarani, hello, Priyanka Mishra, Priyanka, Sony Barla.
Excuse me, sir. Sir, may I say something?
Ask me.
Sir, we must have a blackboard session or whiteboard session also, because you are unable to understand clearly the concept.
Actually, what you are saying, it is right.
Yes, sir.
But till date, the coordinator has not given us that white or blackboard. Actually, mathematics is that like a subject with the blackboard operation. That's why you can interact with us in a good manner, and we can also understand you easily. But actually, what I am saying, it is verbally. But if I shall write something and I can send it to you through a WhatsApp or an email, you can also read that thing and ask me some question. Actually, what I feel, you have some doubt regarding what I am saying in my voice. Do you perhaps some of you do not follow me clearly? What I feel this one. Is it correct? Hello?
Yes, sir.
Now I am
Sir,
repeating.
actually, mathematics is a kind of something numericals and numbers, and now you are saying it theory wise, so we are unable to understand.
Okay. Thank you. Actually, I am repeating it. Perhaps I feel it is somewhat difficult for you. From the next class, will rectify us, and will I shall ask the coordinator to do a blackboard operation in which I shall write something and I shall also send it to you. Or you can see the blackboard and you can ask any question. That is actually mathematics is a subject which always needs some blackboard operation. Otherwise, the verbally, you cannot. Actually, the ignore learners, have you got the textbook or your course structure from IGNO or the study materials from IGNO? Have you got it? Or till
No,
date you
sir.
got it?
Sir, only the first
No,
year,
sir. No, sir.
not the second year books.
This is the second year. What I am teaching you, it is from second year.
Yes, sir. We haven't got books.
This book you have not got.
No, sir.
Okay. Actually, they have told us to cover up all the units in one or two classes. Actually, your course structure is a very heavy one, but you should go through it and then underline something which is difficult for you. Then ask us to describe that thing. Then we can actually, if we go through the course line by line, it will take more and more time. Actually, this is the distance course, not the regular course. And through distance, we can understand your difficulties, and we are also going to solve it in the next class. Okay, that today what I am saying first, what is sequence first. Before going to sequence, you should know what is a function first. Most of the students do not know what is function. Do you know what is function? Sonny? Sonny, do you know about function?
No,
Okay,
sir.
okay. Actually, this chapter starts from the very one that is your function first. Actually, if I will go to the definition of function, it will take more and more time. Actually, you should know about the function from the lower classes. That is from very definition of functions, different kinds of functions. Then one is your how we can describe different types of functions. Now after that, we'll go to this one, that is sequence. Function, that is simply a relation between two sets in which all the elements of the domain are existed, but those elements of domain corresponds or relates the elements of the domain, each one with one and only one elements of the second or the codomain. At that time, we say that that relation is said to be a function. Now, all the students are from Odisha or from any other state. Barsarani Sahu, from which state? Barsarani Sahu. Champa Tudu from what state? What district?
Sir, Mayurbhanj.
That is from Odisha.
Yes, sir.
Next, Priyanka Mishra from what district? Priyanka Mishra? No response. Manoj Mandal?
Sir, from Gajpati.
Gajpati Mayurbhanj. Sonni from what district?
Sundargarh, sir.
Sonni, what I feel, all of you, the learners, those who have joined from Odisha or from other state. Hello? Hello?
Yes, sir.
But do you feel that the language English is difficult for you? Or is it difficult for you? Manoj? Manoj?
No, sir. No, sir. No difficult, but
But
we need, sir, blackboard or whiteboard, sir.
or whiteboard, blackboard operation, this requires for you. Actually, this is the badly necessity for you. Okay, today you cooperate with me. From the next class, I shall ask the learner, coordinator to arrange a whiteboard or a blackboard. That's why you can follow it easily. Next is your monotone sequence. Monotone sequence. Actually, the monotone sequences are defined in the same manner. For example, that is your first of all, the monotone sequence. This is a sequence. Monotone sequence is a sequence. That is, first of all, when we are going to, I had already told you about the bounded sequence. The sequence which is bounded above and bounded below is called as a bounded sequence. Bounded above means the sequence has upper bounds. What do you mean by upper bounds? Do you know it? Upper bounds means this is the number which is larger or equal to all the elements of the sequence, or all the elements or all the numbers of that sequence. For example, I am saying that if fn is equal to 1 by n, this is a sequence, and this sequence has elements 1, 1 by 2, 1 by 3, 1 by 4. Fn is equal to 1 by n. 1, 1 by 2, 1 by 3, 1 by 4, like this. Can you say one element that is always either equal to the elements of this sequence or greater than that sequence? Greater than or equal to, can you say one number which is greater than or equal to this elements of this sequence? Can you say? You can't say. That is exactly 1. 1 is an element, or 1 is the number. All the elements of this sequence are less than equal to 1. No element in this sequence be greater than 1. So that 1 is an upper bound for this set. Or the set sequence is said to be bounded. For example, you can say 2. 2 is also bound and is an upper bound for this set. 3 is also an upper bound. But 1 is also an upper bound, and all the elements of the sequence is less than equal to 1. So the sequence is bounded above. And no element in this sequence be less than this 0. So that 0 is a lower bound for this set. So that the sequence is bounded below. And the sequence is bounded above and bounded below. So that the sequence is said to be a bounded sequence. There is your kinds of, that is your convergent sequence. Then when I am giving some description about the convergence, there are so many sequences. All the sequences are not convergent. In this sequence, so Fn is equal to 1 by n. If limiting value of this sequence xn, when n tends to infinity, that value goes to 0. That is when n tends to infinity, 1 by infinity tends to 0, something by infinity tends to 0. That's why this sequence converges to 0. So that this sequence is said to be a convergent sequence. If xn is equal to 1 by n or fn is equal to 1 by n, and when n tends to infinity, the sequence xn or fn, this goes to 0. And so that the sequence converges to 0 means it is a convergent sequence. Any sequence which is not convergent, it is said to be a divergent sequence. There are so many different types of divergence. That is, I am giving some example of divergence. That is, let xn is equal to minus 1 to the power n. Let xn is equal to minus 1 to the power n. Means when n is equal to 1, that is x1 is equal to minus 1 to the power 1. That is simply minus 1. When n is equal to 2, thus fn is equal to xn means x2. x2 is equal to minus 1 to the power 2. That is plus 1. When n is equal to 3, the next term of the sequence is your minus 1 to the power 3. That is minus 1. When n is equal to 4, that is x4 or f4. That is equal to minus 1 to the power 4. That is plus 1. Like this, the terms of the sequence are minus 1, then plus 1, minus 1, plus 1, minus 1, plus 1, like this. So that this sequence is bounded or unbounded. Can you say? The sequence is said to be, I had already told you or discussed with you that a sequence xn is said to be bounded if it has an upper bound. Upper bound means there is a real number k such that xn is less than equal to k. In this case, fn is equal to 1 by n, or fn is equal to minus 1 to the power n, means xn is equal to minus 1 to the power n. If it is xn is equal to minus 1 to the power n, if I write n is equal to 1, 2, 3 like this, I shall get elements like minus 1 plus 1, minus 1 plus 1, minus 1 plus 1. And in this case, there are elements minus 1 and plus 1. So that 1 is an upper bound for this sequence. and -1 is also on lower bound for this sequence. So that since this sequence is bounded above and bounded below, so the sequence is a bounded sequence. So the sequence is a bounded sequence. But whether this sequence is a convergent sequence or not, and my question is whether this sequence converges to a particular value or not. Actually, this is not a convergent sequence. Actually, this oscillates between -1 and +1. The elements first starts from -1, then goes to 1, then goes to -1, then goes to +1, like this. So it does not converge to a particular value or does not converge to a particular value. So that this sequence always oscillates between -1 and +1. So this sequence is a bounded sequence, but it is an oscillatory sequence, or it oscillates between -1 and +1. ବର୍ଷା ରାଣୀ, ହ୍ୟାଲୋ, ମନୋଜ ମଣ୍ଡଳ, ହ୍ୟାଲୋ ମନୋଜ,
Yes, sir.
ମନୋଜ,
Yes, sir.
what
Yes, sir.
I told you, that is a convergent sequence or not. Convergent means a sequence xn is said to be a convergent sequence if limit n tends to xn, n tends to infinity xn is a finite value. If it converges to a finite value, or it is limiting value is a finite value, then the sequence is said to be a convergent sequence. If the sequence is not convergent, then the sequence is said to be a divergent sequence. I had already discussed with you that is a sequence which is not a convergent sequence, because that I have given an example that your fn is equal to 1 by n. Fn is equal to 1 by n, or Fn is also can written as xn. When I write 1, that is x1. When I write 2x2, 2x2. When I write 3x3, when I write n equal to 4x4, this x1, x2, x3, x4 are the terms of the sequence. Where you can say it as f1 or f2 or f3 or f4. That is fn is equal to 1 by n, or fn is equal to -1 to the power n. I have given these two examples. But in case of fn is equal to 1 by n, that sequence always a convergent sequence, and it converges to, that is your 0. When n tends to infinity, that is 1 by n tends to 0. But if xn is equal to -1 to the power n, but it is not a convergent sequence. This is a oscillatory sequence, and which oscillates between -1 and 2 plus 1. -1, 2 plus 1. Do you follow me, Priyanka? Priyanka? Hello? Hello?
Yes, sir.
Do you listen me? Or am I audible to all of you?
Yes, sir.
Now you are clearly listening me. Or is there any network problem?
No, sir. I
Okay.
have clearly listened.
Okay. Do you clarify about, I had not gone to a difficult one. Simply I am saying what is a sequence, what is a convergent sequence, and what is bounded sequence. Well, what the sequence which is bounded above or bounded below, and then is your convergent sequence. Then is your sequence which is not convergent is called as divergent. And examples of a convergent sequence and a divergent sequence. Till now, I had already discussed with you this one. For next, I am going to discuss about Hello? Hello? Manoj?
Yes, sir.
Okay. Next, we are going to discuss about the increasing sequence and a decreasing sequence. For example, I am asking you about the sequence Fn is equal to 1 by n. In case of Fn, at the place of Fn, you can write Xn also. Fn means F1. I am writing that the Fn is equal to 1 by n. In place of Fn, you can write Xn. Xn is equal to 1 by n. If we write in place of n1, that is x1. If I write 2, x2, if I write 3, x3, those x1, x2, and x3 all are the elements of the sequence. Those are the elements of the sequence. That is, in case of increasing sequence, the sequence xn is said to be an increasing sequence. If for every n or every small n belongs to capital N, if n1 is less than n2, then xn1 is less than xn2. Do you follow me? If n1 and n2 belongs to capital N and n1 less than every n1 less than n2, then xn1 less than xn2, then that sequence is said to be an increasing sequence. For example, there are terms in the sequence that is x1, x2, x3, x4, x5 like this. For example, x1 is equal to 1, x2 is equal to 2, x3 is equal to 3, x4 is equal to 5, sorry 4, x5 is equal to 5, x6 is equal to 6. This is also 1, 2, 3, 4, 5, 6. These are also one sequence. But that sequence is an increasing sequence because the terms are increasing in order. 1, then 2, then 3, then 4, then 5. Sometimes in the competitive exam, there are some questions. There is a sequence and one term is missing in that sequence. That sequence obeys some rule. Then you can find the missing term obeying that rule. For example, I am telling you one sequence that is 1, then 4, then 9. First term is your 1, then the second term of the sequence is your 4, third term is your 9, but the fourth term is not given. The space, that is a blank space. Then the fifth term is your 25. What term will be inserted in that sequence in the blank space? Anybody? Manoj? 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 Sambit? I am asking a set of elements. 1, then 4, then 9, then the term is not written, but the next term is 25. What term will be inserted in that space?
16, sir.
Very good. That is the term in that missing term in that sequence. That is also a sequence. 1, 4, 9, then 16, then 25. This is a sequence. And the first term is your 1, next term is your 4, next term is your 9, next term is your 16, next 25. These are the terms of the sequence. But when we are going towards right, the terms of the sequence are in increasing order. So that that sequence is said to be an increasing sequence. Do you follow me? Hello? Champa Tudu?
Yes, sir.
Do you listen me?
Yes, sir.
That if 1, x1 is the first term of the sequence, x1 is equal to 1, x2 is equal to second term of the sequence, that is 4, x3 is equal to third term of the sequence, that is 9, like this. So x1 is less than x2, x2 is less than x3, x3 is less than x4. So the sequence is said to be an increasing sequence. The terms of the sequence are in increasing order. But how can you define a decreasing sequence? Like this, for n1 and n2 are two natural numbers or belongs to capital N. If n1 less than n2, but xn1 is greater than xn2, then that sequence is said to be a decreasing sequence. Do you follow me? Priyanka? Hello? Priyanka? Manoj?
Yes, sir.
Yes, sir.
So then what is the difference between sequence and series?
Hello? Hello? Hello?
Yes, sir.
Very good question. That is, what is the difference between a sequence and a series? These are the terms of the sequence, what I now told you. But the sum of the terms of the sequence is known as the series. That is the sum of the terms. Do you follow? Hello?
So it means the total elements in the
For example, I am writing that. Do you know what is AP series and GP series? Hello? Arithmetic progression and geometric progression. Simply arithmetic progression and arithmetic series and geometric series. That is your, and this is your first. I am writing that 1, 3, 5, 7, 9. This is in the arithmetic progression. And the arithmetic series is 1 plus 3, then 5, then plus 7, plus like this. Do you follow?
got it, sir.
Priyanka,
Yes, sir.
do you follow me?
Yes, sir.
Okay. Now when we are saying that a sequence xn or fn, if xn is equal to 1 by n, then when I write in place of n equal to 1, that is x1 or the first term of the sequence. If I write 2 in place of n, that is x2 is the second term of the sequence. Like x3, third term of the sequence. If I define the sequence as xn is equal to 1 by n, then the first term of, I had already told you what is the domain of the sequence. The domain of the sequence is the set of natural numbers. I can write in place of n, that is 1, 2 or 3 or any value. But in place of the codomain or range, we will get the real numbers. Here is in the domain, we are only the set of natural numbers. That is your n equal to 1, that is x1, then x2, then x3. In place, if fn is equal or xn is equal to 1 by n, then x1 is equal to 1, x2 is equal to 1 by 2, x3 is equal to 1 by 3, x4 is equal to 1 by 4, x5 is equal to 1 by 5. Now, please see the line or the elements of the sequence. That is a 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6, like this. When we are getting the terms or the elements of the sequence, that is your x1 first term of the sequence, x2 second term of the sequence, x3 third term of the sequence. But in case of this one, in this example, when n, the value of n increases, but the value of the term decreases. For example, the fourth term is bigger than the fifth term. The fifth term is bigger than the sixth term. And the sixth term bigger than the seventh term. So that the sequence is a decreasing sequence. Do you follow me? Manoj? Manoj?
Yes, sir. Yes, sir.
For example, 1 by 2 and 1 by 3. Which one is bigger?
1/2.
1/2.
1 by 2. Then 1 by 3 is less.
Lesser.
1 by 3 is less than 1 by 4. Sorry. Sorry. When the first term of the sequence is what one? The first term of the sequence is your 1. x1 fn is equal to 1 by n. The first term of the sequence is 1. Hello?
Yes, sir.
Then the sequence next term is
1 by 2.
2. Then your
1 by 3.
the first term is 1. Then the next term is less than that. Okay?
Yes.
The third term is less than the second term. Hello?
Yes, sir.
The fourth term is less than the third
Less
term.
than the third term.
Like this, so that the terms of the sequence are increasing or decreasing. When the number of
Decreasing.
increases, then the value of the sequence or the value of the terms decreases. When we are going to the fifth term, it is less than the fourth term. Okay? Hello? Hello?
Yes,
Yes,
sir.
sir.
The fourth term is less than the fifth term. The terms are actually decreasing, and in the last stage, when n tends to infinity, that term becomes what value? Hello?
0, sir. 0.
It becomes 0. When so that term for example 1 by 2 and 1 by 3, take a object and divide it's 2 times. So 2 times and take 1 time, that's 1 by 2. Take a term and take one thing and divide it by 3, or divide 3 times or 3 division and take one of them, that is 1 by 3. So naturally 1 by 2 is greater than 1 by 3, and 1 by 3 is greater than 1 by 4, and 1 by 4 greater than 1 by 5. Naturally the terms are in a decreasing order, so that this sequence is said to be a decreasing sequence. Do you follow? Hello?
Yes, sir.
Hello?
Yes, sir.
Yes. Okay.
Yes, sir.
But have you clarified with it whether which one is a decreasing sequence and which one is a increasing sequence?
Yes,
Hello?
sir.
In case of,
Yes, sir.
in case of increasing sequence, when the number of terms increases, then the value also increases. But when the number of terms increases, the value of the term decreases in case of
Decreases.
decreasing
Not
sequence.
decreasing sequence.
Okay, decreasing sequence. That's why that is the difference between a increasing sequence and a decreasing sequence. That is, or next we'll go there. That is, I am giving some examples about. I had given an example that is xn is equal to minus 1 to the power n. That is a sequence, but it oscillates between minus 1 and plus 1, and it is a bounded sequence. First of all, it is a sequence. It is but I had already told you what about the bounded sequence. If fn is equal to or xn is equal to 1 by n, is it a bounded sequence? Hello?
Yes, sir. Yes, sir.
Which is the upper bound? Please say one upper bound for that sequence.
One is the upper bound, sir.
Very good. Which one is the one? Can you say one of the? There are so many upper bounds. There are so many lower bounds. But how many? What is the lower bound for this sequence?
0, sir.
Very good. Or any negative number is also a lower bound for that set.
Sir, but negative
No.
number possible or not?
Actually, negative numbers means when we are saying about, for example, I am saying the fn is equal to minus 1 to the power n. That sequence also contains negative and positive numbers. Fn is equal to minus 1 to the power n.
Yes, sir.
Hello?
Yes, sir.
That also contains that Fn is equal to 1 minus 1 to the power n. That sequence only contains two elements. That is your plus 1 and minus 1.
Yes, sir.
Hello?
Yes, sir. Yes,
Okay. But I am, for example, I am giving an example of a set simply. For example, I am giving a set 10 to 100. Set up all natural numbers between 10 to 100. Any element or any natural number greater than or equal to 100 is one upper bound for that set. Do you follow? Hello?
yes, sir.
Yes.
Any number which is less than or equal to 10 is a lower bound for that set. Do you follow? Hello, Manoj. Any number either 10 or less than 10 is a lower bound for that set. Since this set is bounded above and bounded below, so that set is a bounded set. Not this is not set sequence. This is set. I'm saying about the set first. Any natural number 100, 101, 102, 103, 104 up to infinite, all are the upper bounds for that set. Then this is your 10, 9, 8, there are also the elements which are lower bounds for that set. Since it has upper bound, so it is bounded above. Since it has lower bound, so it is bounded below. Like that, sequence is, if all the terms of the sequence is less than or equal to a particular number, then that number is said to be an upper bound for that sequence, or any number which is less than or equal to all the terms of the sequence, then that number is said to be a lower bound for that sequence. Any sequence which is bounded both or bounded above and below is said to be a bounded sequence. If it is one-sided bounded but not bounded both sided, then it is not at all a bounded sequence. That is an unbounded sequence. Okay. Next, I am giving another example. Let xn is equal to nq. Xn is equal to nq. When n is equal to 1, x1 is equal to 1. When n is equal to 2, x2 is equal to 2q, that is 8. When this is x3 is equal to, that is 3q, 27, like this. Whether this is an increasing sequence or an decreasing sequence.
Sir, increasing, sir.
Very good. Whether this is a bounded sequence or an unbounded sequence.
Unbounded, sir.
Unbounded sequence. It has a lower bound, but not an upper bound. The lower bound is 1. The sequence starts from 1, then there's your 8, then 27, like this. This is an unbounded sequence. Whether this sequence converges to a particular value or a convergent sequence?
No.
No. Since when n tends to infinite, this nq tends to infinite. So this is not a, this sequence. This is a sequence which is unbounded, and when n tends to infinity, the limiting value of this sequence is infinite. So this is not a convergent sequence. Okay. Okay. Do you clarified about the convergence or divergence? There are different types of divergence. That is your one is your bounded but oscillatory sequence. It is also bounded, unbounded, or unbounded but oscillatory. That is also is kinds of divergence. That is unbounded and a limiting value infinite. That is one type of divergence. Unbounded and limiting value minus infinite. That is also one type of divergence. For I am giving an example. For example, xn is equal to minus 1 to the power n into 2 to the power n. Xn is equal to minus 1 to the power n into 2 to the power n. When I write n is equal to 1, that is minus 1 to the power 1. that is your -1, and a 2 to the power 1, that is 2. The entire value is -2. When n is equal to 2, that is x2 is equal to -1,
16.
-1 to the power 2 plus 1, and then 2 to the power 2 to the power 2, that is 4. 4, that is plus 4. First is your -2, then is your plus 4. When n is 3, that is -1 cube, cube of -1, that is -1, and a 2 to the power 3, that is equal to 8, that is -8. When I write 4, x4, that is -1 to the power 4, that is plus 1, 2 to the power 4, 16. But can you say the sequence is increasing or decreasing? This is
Increasing.
actually, this sequence is in positive direction, it increases, and in negative direction, it also decreases. So that this is not increasing or decreasing, this is an oscillatory sequence. It goes to positive and also come back to negative, then positive, negative, positive and negative direction. So this sequence is also an oscillatory sequence. This is one unbounded, it has no upper bound and lower bound. It is an unbounded sequence and also oscillatory. Actually, learners, the time now the time is over. But I request you, if you have not that book from your IGNO study IGNO center, please first of all, please go through the book either in form of papers or in internet. Then you ask me, lead that, and if you have any doubt, then ask me in the next class. Actually, I am asking the coordinator to arrange a whiteboard. That's why I shall write something and you can follow it easily. Thank you all. Now I am going to end the class. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.